Hi and welcome to this video. In the previous video, I showed you how you could aggregate a stream of salaries using Speedment and compute the average and the variance of the salary value of all the salaries between $60,000 and $80,000. But what happens if you have multiple tables that you need to aggregate? So say for an example that I want to do this same operation, but I want to compute it depending on which gender the different employees have. In that case, I need to access two different tables because I have the salary table that contains the salary information, but then I also have the employee table that has the gender column. So there is a previous video where I showed you how you could use the join component to get a joined stream of two different tables. But now I'm going to show you how you can do that with and combine it with the aggregator. So first off, just as in the previous time we did this, I'm going to get the join component from the Speedment application. So take app.getThrow join components. So when I have this, I can write .from to get a join builder from a particular table. So I'm going to take the employee table and say employee manager.identifier. Next, I need to specify which column in the foreign table I want to join with. So I'm going to say inner join on salary employee number. And then I need to bind that to the first table I had, the employee table. So I'm going to say equal employee, and it's also called emp number. So when I have this, add the filter. So you saw here, down here, I used a filter salary between $60,000 and $80,000. So I can copy paste this and just put it into the variables. And then I can build it. So now I've created a join over two different tables, the employee table and the salary table, with the constraint that for each employee emp node, I'm going to find a corresponding salary emp node. So we could let IntelliJ generate a local variable for this and just call it join. And here you see that I have this tuple2 of nullables. And that is really because Speedment doesn't know if all of these are going to be present or not. Maybe when we have a left join, for example, we could have certain tables being null in the join statement. But in this case, we have an inner join, so we could force this to be non-nullable by writing tuples : off, and then remove off nullables up here. So now we have a non-nullable join statement. So down here, you saw how we used the aggregation previously when we just had the salary manager. So now we're going to do pretty much the same thing, but we're going to do it on the join stream instead. So first off, in this example, since we were aggregating a single table, we could do it in one single statement like this. We could begin by just retrieving the stream over that table, and then we could filter it and collect it. But I'm going to start with this inner part here and just do the aggregator builder first so we can take it step by step. So I'm going to write aggregator builder and then specify how the result object that it's going to hold the results from stream is going to be created. So I'm writing results : new. And then given that, I can start specifying what I want to do in this aggregation. And you remember previously when we just had one table, we could just write .on and then the field that we want to operate on, and then the operation. But now, since we have multiple tables in join, we first need to specify how to access that table. So that is called first on. So first on, and then we take tuple2 getter, and I want to do the same operation as here as the average. So I take the getter 1 because I want to access this table in the join, the second table. So like that. Then when we have done that, we can then say and then, and put the field that we want to access. So that's salary. And then lastly, we can take average. And just write result : set average. And then build. But you notice that IntelliJ shows an error here. And that is because when you're creating a builder like this and you're operating on multiple tables in the same statement, then Java kind of loses the type information here because we have two different tables here in a generic statement. And here we only mention one of those tables, the second generic variable. So when we come to this line, we have lost any type information about the first one. So to be able to continue carrying on the type information, we need to manually specify the generics here. It's a little bit irritating, but it's not that much of a problem. So I'm going to write employee and then salary, just to help Java along a little bit. Now we see that it compiles. So we added the first operation. So let's add the second one. Let's say first on tuple 2. And I only have to mention this the first time because now the type information is in chain. So I can just write getter 1 and then say, and then salary, and then say variance, result set variance. Great. So now we have created the corresponding aggregation as down here, except that we are doing it on the join here. But how do we get access to the employee information? I mean, the initial thing we wanted to do here is that we wanted to aggregate the different genders to compute the average and variance salary for each gender category. So we need to get that into the result somehow. So first off, the result object I created up here, I'm going to have to add a column here. So I'm going to write private string gender, because the gender is a string column in this database. And then I'm going to regenerate these setters, so I get the gender column as well, and regenerate the toString method. So now I have the result object with the additional gender information. I can set it with the setter, and I'm going to include it in the toString method. So down here now, we can add a third operation. So we take first on, this time we want to access the employee table. So I'm going to take tuple to getter 0 this time. And then employee gender. And then to the aggregation operation that we want to perform. In this case, we want to define a key, something that the aggregation can group the different results by. So I'm going to write key, and then I can store away the key value in the results. I'm just going to write result set gender. So now we have created an aggregator that performs 3 different operations. It groups all the incoming joined entities by the gender, and then it computes the average and the variance of the salary column. So now when we have this aggregator builder, let's operate on, let's use it in a stream. So I'm going to take join.stream. You see that this will give me a stream over tuple 2. I can use that, and then I can say collect, and then I can use the collector that I get by taking the built aggregator, and I'm writing create collector, like this. But you remember from the previous example that the result of this shows up if I create a local variable, is an aggregation. So we need to call the stream and close method to be able to get a stream that we can iterate over. And the reason for that is that a single aggregation can be used multiple times without having to recreate this entire operation. So now when we have finished, let's run it. And here you can see that I have grouped, I got 2 results now. Previously I only got 1 result, but now I've got 2 results, one for females and one for males. And we can see the average and the variance of salary in each category. So this really shows you how we can chain together multiple operations and operate over large streams over multiple tables in one single stream. So thank you for watching.